Hello again, everyone. I hope everyone's enjoying dinner. Okay. It's good? Dinner's good? Awesome. So I'd now like to introduce a special guest, John Cornish. So John was recently elected the 15th Chancellor of the University of Calgary. So he's a community leader, fearless problem solver, and a Canadian Hall of Famer who works with various nonprofits and charities around Calgary. He's also the founder of the Calgary Black Chambers, a nonprofit working to make Calgary the best place to live and work for BIPOC people. So we're very excited to have him here with us today and see how he plans to make our campus community a better place for all. So let's welcome John.
Thank you, Brittany. I do got to say the people at the Red and White Club are very adept at serving great food. I love the chicken tonight. Can we give them a big round of applause? Beautiful. Welcome, everyone, to the 7th Annual Legacy Society event. President McCauley, unfortunately, couldn't join us today, but I'm happy to be here in this place to meet all of you. It's an honor to share this room with some of our most loyal supporters. I'm only a few months into my role as Chancellor, but what was clear to me from day one was just how passionate our philanthropic community is and how much we've accomplished working together. Thank you for your existing and potential contributions to our great University of Calgary. As you may know, we've had a tremendous amount of success in recent years and are now recognized as a top 5 university in Canada. It truly is outstanding and marks how far we've come because we're the fastest university to reach that point as we are still one of Canada's youngest universities. We've also recently passed the University of Waterloo as a university producing the most entrepreneurs, people creating change in the way we do business and how we live our lives. The late Senator Daniel Patrick Moynihan of New York is often credited with saying that to create a great city is to create a great university and wait 200 years. I think we at UCalgary are moving a bit faster than that. All the accomplishments we've achieved and are able to achieve are a result of the philanthropic community who are passionate about shaping the future of our university. We recognize your extraordinary support. I know when I first came to Calgary, I was blown away by the amazing support that the community gives to those around them. First as a volunteer working at the Alberta Children's Hospital as one of the hundreds of people who give their time to help. And then during the 2013 floods, when all of Calgary stepped up to help each other. Working with Woods Homes, the Alberta Ballet, and other community groups showed me that, many of these groups that we take for granted simply would not exist without the continued support of thoughtful individuals like yourselves. As I've come to learn more about the university, I've begun to understand how a great university necessitates a thriving community. Looking back at my days in university, I wasn't a Chancellor Scholar. I said it. I could only wish I was as remarkable as those students. But I was pretty good at football. And this allowed me to have an opportunity to have a relationship with my chancellor, the late Bobby Hemingway. He shared a value with me that I continue to champion today. It's not about how much you can help yourself, but how much you can help those around you. I, like you in this room, hold this to be true. You have the perspective to see further than the next 5, 10, or 20 years. Our legacy donors are a visionary group of people who seek a future beyond our lifetime. Your gifts are meaningful in their expression of your life's work and what you leave behind for generations to come. You too, as Legacy Society members, inspire others to take part and contribute to initiatives that benefit our campus, community, and the world, creating momentum, elevating our city. Your gifts support numerous initiatives across our institution, from building innovative teaching and learning spaces and creating strong community ties, both at the local, national, and international levels, as well as contributing to life-changing research, like the topics you'll hear about tonight. Like our president, Dr. Ed McCauley, I believe a top 5 ranking in Canada is significant. It's good. It's a testament to the direction we're heading. However, it is our sincere belief we should continue on this trajectory. As UCalgary's leaders, we seek to compete with the MITs, the Princetons, and the Oxfords of this world. By the way, just in the last 3 years, we've had 4 Rhodes Scholars, and the University of Calgary has had 18 Rhodes Scholars to date. Truly, with your support, anything is possible. So let's start something together. It is our privilege to say thank you to all the members of the Legacy Society for demonstrating your leadership, your passion, and your commitment to our university's future. Thank you. Save the whistles for the football games, thanks. And I would like to welcome our Vice President of Advancement, Dr. James Allen, to provide some insight on how your philanthropic investments support UCalgary.
Hello, everyone. For those of you I haven't met, my name is James Allen. I'm the Vice President of Advancement here at the University of Calgary, and I have learned a valuable lesson this evening, which is don't go on after John. He's very good. Thank you so much for joining us this evening. I'm really pleased to have the opportunity to speak to you all. It's been a long couple of years of virtual meetings and events, and so it's a real pleasure to be able to get together in person. And thanks again to the team who put this together tonight. We're all a little bit rusty, but tonight's been flawless, so well done. These things are not easy to do. I'm a new Calgarian, and I joined the University of Calgary just earlier this year, and it's been an exciting 8 months, and I've learned a lot. So I got to go to my first Stampede earlier this year, which was amazing. I no longer get to say it's my first rodeo. But one of the things I learned, well, so it was a blast, but one of the things that was really, really interesting to me was to learning how deep the roots in the community are. I met people who had been in the show band 50 years earlier, right? The depths and roots of that work were really astonishing to me, and that was really phenomenal. More recently, just a couple of weeks ago, we held a celebration for all the alumni who graduated in 2020 and 2021 who were not able to walk across the stage and have that graduation experience because of COVID. We had them back on campus. Over 2,000 young alumni came back and had that moment, and what they wanted most was to walk across the stage with their parents watching, to take the picture, to have that moment. There was also a pretty good football game. And some of us in the room may have fired a t-shirt cannon or two into the audience, which was a good time. But what was amazing was really how passionate and eager those young grads were to come back and stay part of the community. And those two things together, the sort of depths of community that I encountered at the Stampede and the sort of passion, even among our newest grads, was really, really striking to me. And so I thought I'd mention it here this evening because this community, you and your support are part of that continuum. And it's really powerful stuff. And to be clear, not all places are like this, right? I've worked at a number of different universities in a number of different cities, and there's something special here. And I think that's really quite remarkable. So thank you for that. But tonight, we're really celebrating you, our philanthropic community. As John shared, we've made some great strides recently, and you've really helped us get there. When I look around the campus, there's hardly a single faculty or program or project or even a building that hasn't been touched by philanthropy. And the gifts our Legacy Society members have pledged will take us even further. By including a gift to UCalgary in your estate plans, you're investing in the future, in the next generation, in our community. And I'd like to thank you really, really thank you for sharing in our vision and placing your trust in the University of Calgary to help create that brighter tomorrow together. We're about to hear about some really wonderful work. The work that Dr. Jaideep Bains will share with you tonight is just one of the examples of the extraordinary research happening here at the university, research that is supported by philanthropy. UCalgary is home to the Hotchkiss Brain Institute, which conducts groundbreaking research that improves brain health and increases quality of life. And in partnership with the Hotchkiss Brain Institute and UCalgary's Department of Psychiatry, the Matheson Center for Mental Health and Research and Education is dedicated to advancing research and education on early identification, treatment, and mental illness. But before we hear from Dr. Bains, I'd like to share one story with you from one of our Legacy Society members. Paul Stortz is not only a legacy donor, but also an associate professor in our Faculty of Arts. In 2017, he established a scholarship in memory of his wife, who was also a beloved member of the UCalgary and Workland School of Education family. Let's meet Paul now and see the difference he's making. I think we have a video.
My name is Lisa Panayotidis, and with my co-investigator Paul Stortz, I edited a collection called Historical Identities, the Professoriate in Canada.
We were soulmates from day one. It was one of those, fall in love right away. We met at our program at the University of Toronto in 1991. It was the very first doctoral seminar, and then we met at the elevator, and that was it. When Lisa passed away, the flood of sorrow and of letters and emails to me, the impact she had was tremendous. Lisa got hired at the Workland in 1997. She was a professor there. She loved everything about it. She was doing a history and theory of visual culture, theories in education, pedagogies, curriculum. She was identified of being an up-and-comer for administration. But when it came down to it, she really loved her research and writing, but in particular, she loved students. She would make sure not only that they are doing well in school, but off campus and in life in general. I started thinking about the legacy gift right away. What's really important about the legacies is that it is directed not only to the well-being of the student, but the well-being of the collective.
I'm researching on anti-Black racism invigorated by police brutality. When news came to me that I had received this scholarship, I was honored. It was a confirmation that my work is aligning with Lisa's work, which was kind of a dream come true for me. I've taught for 23 years and I've taught graduate students. They all complain about racism. It's more of a systemic issue. When I see people, showing signs of racism, I don't blame them. I blame the system, and the system is historical. That's the mindset that we need to reverse, not just in white people, but also in Black people and everybody. My research is about a conversation. We need to see them empowered to take action, to do more about their communities. Lisa focused on social, cultural, and interdisciplinary studies. She was also a critical thinker. And you cannot do anti-Black racism or anti-racist work if you're not a critical thinker. You have to critique theories, practices, behaviors. You have to work towards change. It's not about pointing fingers. It's not about fighting. It's about a dialogue. Because when we fight, one wins, one loses, and the fight keeps on.
Whenever I think about it, I see her face. The endowment represents her mind and her compassion and her humanity. It represents who she is. What students hopefully take away is all of that. It's a love letter to the students, and what she used to say often is that she would like to see students graduate with a critical mind and a big heart.
Forgot to flip. What a wonderful message that was. I should have listened to it earlier so that I wasn't so emotional right now. So this year's topic is stress in the brain, which is exploring UCalgary research in the area of brain science and mental health. So we're really fortunate to present, fortunate to present our distinguished guest, Dr. Jaideep Bains. So Jaideep is the scientific director for the Hotchkiss Brain Institute, as well as he leads the mental health initiative for stress and trauma, and his work focuses on how stress impacts the brain. And so let's please welcome Dr. Bains.
Not on. Microphone is on. Awesome. Thank you. Thanks, everyone, for coming. It's really a delight to be here. And how cool is it that we have John Cornish as our chancellor? My goodness, hey? So I remember watching John play. I was 9. No, I wasn't 9. And I loved watching John play. And what I loved about him is you could tell that John was thinking his way through the game. It was amazing to watch this. I was sad when he retired, but my goodness, he gave us some great, great years. So I just want to pick up on one thing that John said when he referred to the University of Calgary as being number 5. And I think, what he was hinting at is that number 5 is not a goal, it's a signpost, right? It's a step up to the top. So we're just saying, thank you, number 5, let's move on up. I think that is our collective goal, right? We want to be the best university in Canada, and that's where we're headed. So let me tell you a little bit about myself, and then let me tell you about the work that we do in my lab, what my passions are, and where I think we can make a difference. So I am a PhD neuroscientist. I was trained at Queen's University, and then there's always a Queen's person in the crowd, too. Fantastic. And after my training at Queen's, I moved to the University of Colorado in Denver for more training, because once you get your PhD, it's just not enough training. You need to do more. So after 3 years in Denver, I was recruited to the University of Calgary, and we were delighted to be here. My wife is a Prairie girl, and so this was the top of our list of where we wanted to be. And I can tell you, since 2001, we have enjoyed every single minute of it. It has been fantastic. And I've been really fortunate to work in the Cumming School of Medicine with some outstanding colleagues, in the Hotchkiss Brain Institute with some terrific folks. And I think what we've built and we continue to build is really going to be transformative. So the work that I do, I'm going to break it down into 3 different parts. And what I'd like to do is tell you about 8 minutes on each part, and then Brittany we're going to have a little Q&A back and forth. It's almost like my PhD defense. She's going to ask me questions just to make sure I get everything right. So I'm going to focus on three parts of my work. The first part is going to focus on stress. How many of you are stressed? Yeah, so whenever I tell people I work on stress, they're like, hey, work on me, because I know what this means, right? So the first part of my talk, I'm going to focus on what stress is, so the neurobiology of stress and how we understand it. I'm also going to focus on how the brain changes and adapts to stress. And the point I want to make in this first 8 minutes or so is that stress isn't something that's kind of nebulous and hard to pin down. We understand it really well. And the changes that it causes in the brain are actual real biological changes to specific molecules and to specific connections between cells in the brain. And I'm going to talk about that in the first part. And in the second part, I'm going to talk about a really interesting area of research that we have gotten into in the last few years that talks about stress controllability. I'm sure if I were to ask John Cornish, what stresses you more, getting the ball on a 3rd and goal or waiting for a referee to make a decision on an instant replay, he would probably say the second. The reason he says that is because the first stress is controllable for him. He has a lot of control over the outcome. The second stress, he has no control over, right? it's completely uncontrollable. And so those two types of stress, although those events are both stressful, they leave very different imprints on the brain, okay? And so I'm going to talk about that in the second part. And in the final part, I'm going to talk about something that seems a little bit odd, but I think if I ask you a question, maybe you'll all understand what I'm talking about. How many of you think that you can sense other people's stress? A few, quite a few. Yeah, mostly women. Interesting. Okay. So the last part of the talk, I'm going to talk about some work we've done in the lab in just the last few years that started kind of on a whim. And the whim was, I wonder if stress is contagious. Because there was little snippets, right, in the medical literature of, work done on medical students that if a few were anxious, the rest got anxious and their test scores got worse. It was kind of interesting. But we weren't really convinced by it. And so we wanted to see if we could pin down an actual biological mechanism through which stress was transmitted from one individual to another, okay? So that'll be the last part of the talk. So Brittany, I'm going to count on you to keep me on time, because if you just give me a little, your time's up, that'll be great, because I could talk for an hour and a half, I think. So, so one of the things we've learned in my lab, and the work from many other labs, I don't want to take credit for all of it, is that stress initiates this kind of cascade of events in your body. You feel stress, right? You feel it here, you feel it in your heart, you feel your body tightening, because the stress response is actually part of a survival response, right? It occurs because you and every other animal that came before us in evolution had to figure out how to survive. And so when stressors, right, when you encounter stressors, whether it's a predator for an animal or a deadline for you, that sympathetic nervous system that increases your heart rate and increases your blood pressure, right, quickens your breathing, that kicks in right away. And that is what we know and have heard of as that fight or flight response, okay? So that response for most stresses is good. You want that, because without that, most organisms don't make it. The second part of the stress response, in addition to changing some of your behaviors, is what's an endocrine or hormonal response. And so this part of the stress response is controlled by an area of the brain which is very, very deep in your brain and is made up of only a few thousand cells, okay? So if you think about your brain as having 10 billion cells, leaving this really critical part to just a few thousand cells seems to be putting a lot of weight on these few cells. And so what this part is that these cells secrete hormones into your blood, which eventually results in the release of a hormone called cortisol. So you've probably all heard of cortisol in some way. It's the stress hormone. And cortisol is really a signal to the body to prepare. It says, get your glucose stores ready, we're gonna meet a challenge, and I'm gonna need to recover, okay? But cortisol also does a lot of other really interesting things. It has immediate actions on the brain. In some parts of the brain, it parks your ability to remember information, right? In other parts of the brain, it enhances your ability to remember information. And so these systems that you need to survive, like these tiny little cells, these 5,000, 10,000 cells in the brain, or the areas that control your fight or flight response, they seem to take all this information in really well, and they seem to sensitize to stressors. Whereas other parts of your brain that you know, maybe are required to do math or figure out an equation, those parts, they don't do so well. So you can see how stress can both promote learning in the brain and hinder learning in the brain. It's just what type of learning. Your brain is learning, but it's learning different things. And it's this learning that happens in these brain areas that are the kind of controllers of those basic stress functions that we are really obsessed about. So we try to understand how a single stress, so we don't work in people, we work in mice. Mice is our model of choice because this brain area in mice is very, very similar to what we have in people. And so we can use different experimental tricks in mice that you do not want me to do to you. And so that gives us an insight into how brain cells in these stress areas communicate. And so one of the things that we've discovered is that a very brief stress to a mouse, and you can stress a mouse in a number of ways. If you put it in a bucket of cold water and you make it swim, it's pretty stressful for a mouse. And when we do that, we can detect imprints of stress at the cellular and molecular level by measuring the signals between the cells. The signals between the cells get stronger, and even for very small stresses, they remain increased for days in a mouse, okay? And so you can think about what an intense stress might do for us, how our brain might take in this information and how this information might imprint, and by imprint I mean leads to some chemical changes in our brain that may not change our actions immediately, but may lead to different actions the next time we're exposed to that stress, okay? And so those are the types of things that we try to understand. And so that work has been kind of ongoing in my lab for about 12 years or so, and we're slowly just kind of pushing the envelope forward in that type of work, right? And so there's a large effort in the lab, a large group of postdoctoral fellows from all around the world, graduate students and technicians who help us work on this. And when we look at this, not only do we look at the cells in the brain or the circuits in the brain, we look at the behaviors of mice. And now there are very sophisticated machine learning behavioral tools that are starting to tell us, almost translate for us, what mice are thinking and doing before we can even detect it with our own eyes. So this is kind of where the cutting edge of neuroscience is going. So maybe I'll stop there and I'll let you start with questions, and then we'll move to the next part.
Okay, I have a mic over here. I was told to pause. Okay. Yeah, maybe I'll just stand here instead of come way up to you. Yeah, thanks so much, Dr. Bains. So just to give you some, is this working? That's okay. Yep. Some perspective. So me and Jaideep got to talk a little bit yesterday. We do similar things in very, very different ways. So he's a neuroscientist. I'm a social psychologist. So I see things very differently than him, but also we understand each other a little bit. So yeah, so I guess my first question that I thought of is, so our work is really focused and shifting toward this idea, this realist approach, if you will, that we want to know not just what works, but what works for who and in what circumstances, because we're all diverse beings. So my first question is, how do different people respond to stress differently? Is stress different in different folks? Like, how does that work with diversity?
Yeah, that's a good question. So I think overall, the general stress response that I described, the physiology, meaning the heart rate, the blood pressure, the hormones, those are going to be the same. Your sensitivity to a stressor will be widely variable, and that's going to depend on your genetics, your own personal experience, the situation you find yourself in. So those are going to be very, very different. And so this is the challenge. One of the challenges, right, when we try to think about what we do as neuroscientists and what you do, Brittany, at your level when you work with people, is that we have a very controlled environment and we can start to understand all these mechanistic details. You go out in the real world and every single person is a unique being, right, as you said. And so it's not that the stress response itself, the way it's built, is different. It's really not. But the threshold for activating it and what might trigger it in one person will be very, very different than what will trigger it in another person.
Awesome. Yeah, and so like in our work, we talk a lot about like the word resiliency is being used a lot, and it used to be this something where folks used to think we're born with resiliency, we're born with grit, and if you aren't born with it, so that's sucks for you. But now we know it's more of a learned behavior, right? It's something you can actually train in yourself, which is a very positive thing that we've kind of figured out. So I was just wondering, if you could speak a little bit to resiliency and how you see that from your perspective.
Sure. Yeah, so in the neurobiology of stress world, we think about resilience as the opposite side of the coin as vulnerability, right? So you have individuals who are highly vulnerable and others who are highly resilient. And so can you teach resiliency? Can you teach systems in your brain through training to become more resilient? And based on the work that we've done, I would say the answer is yes, definitely. So in the second part, which I'll get to in a second, controllable stress, or putting individuals in situations that are stressful but over which they have control over the outcome, makes them more resilient. Just like if you put people into situations where they have no control over the outcome, it increases vulnerability. And so I think, in some therapeutic approaches, like these are used in clinic, right, to try to enhance resilience. What's really interesting is that, and what I'm really fascinated by is that, one of the things about stress is that it's kind of invisible, right? Like you wouldn't always know that somebody else is stressed. Andrea and I were talking about this last week about asymptomatic stress, right? So there is a little disconnect between the behavior outward and what goes on the inside. And some of us are really good at uncoupling those things. So the world never knows, right? Because we just know, or we just think we have to get on with things. And so you can't let on you're stressed, right? Whereas others, you can see it all the time. And so I think it's fascinating to try to understand what is going on internally at the level of an individual's emotions and what goes on outside at the level of their behavior. Sorry, I went away from your question a little bit, but
like a true academic. No, I like the answer was yes, because I was like, we really would like that to be yes. Do you want one more question, or do you want to shift into your
I can shift into the second part.
Perfect.
Yeah, cool, thanks. Okay, so what I want to do for the next few minutes is just talk a little bit about stress controllability. I don't think Brittany and I rehearsed this, but I'm glad Brittany asked me that question on resilience and vulnerability. So this is a really, really interesting field that neurobiologists, psychologists have thought about for a long time. And it starts with kind of an old experiment done probably in the 70s. I know, sorry, for some people 70s is not that old. But in the 70s in rats, right? And the experiment is really simple. If you shock a rat and you don't allow it to escape the shock, right? That's one group. And another group, you shock a rat, or you play a sound and shock a rat, but before it shocks, if it runs away, it doesn't get shocked. So the second rat is said to have control over the outcome. It can hear the tone and go, I'm out of here. It crosses over to another side of the cage and it doesn't get shocked. The other rat, regardless of what it does, it's going to get the shock, right? And so you start to build two phenotypes, or two types of personalities, if you can call a rat a person, two types of personalities in these rats, right? Resilient personality, the one that has control and that can run away, and the vulnerable personality, right? The one that regardless of what they do, they're going to get shocked. In the end, the number of shocks each rat gets is the same, because this one only gets shocked when this one gets shocked. Okay? So if this one never gets shocked, this one won't get shocked, but it doesn't know why this is happening, right? And so that gives us a really great model. It's a pretty good real world model, actually. We can all in our heads think about situations in which we might have zero control, and almost the exact same situation, like in terms of the stressor, where we might feel like we have a lot of control. And so what we've learned over the years is that in people, if you have people and these are largely based on interviews that were conducted with people who lived through atrocities, who lived in war zones, who were subjected to natural disasters and things like this. So you had people exposed to the same thing, but what they learned is that the individuals who felt like, I got this, I'm gonna get through this, and took action to take control, appeared to show fewer symptoms, negative symptoms down the road in their life, whereas individuals who felt like, this is not going to work. It's not working out. It's really hopeless. Those individuals tended to, and I'm using my language very carefully, tended to show more negative symptomology later on in life. And so those types of studies, they're partly anecdotal. They're not super well statistically powered, but they give us an idea to do a set of experiments. And let me describe one of the experiments that we did, because it's a super simple experiment, and we're continuing on with this to start to understand whether we can use a type of controllable training to override in individuals uncontrollable responses to stress. So the experiment is kind of a cool experiment because in mice, because it relies on the fact that mice have a natural predator that comes from the sky like this, right? So if you've been in a field, you've seen, right, a hawk or a falcon, and they're sitting there doing this, and then they go like this. And so we can recreate this in the lab in a really cool way, right? So we can just take a computer monitor and we can create a little shadow on it, and we can make the shadow expand like this. And so the mouse looks up, and there's a little house, a little shelter for it, and when it sees it, it runs to the shelter, right? And so mice have this natural affinity to just do this. You don't have to teach them. They just know to do this. And almost all the time, this is what they do. But if you take a mouse and you train it, so like the tone and shock thing I told you earlier about, if you train it to not be able to escape a shock when there's a tone, now when it sees this shadow 3, 4, 5 weeks later, which is an eternity in a mouse, right? It just freezes. It doesn't make that dash anymore. And so what we wanted to know is where in the brain is this information being stored? How the heck does the mouse take this information about this stressor, which was a shock, and go, oh, when I see the shadow, I'm not going to be able to respond. So it turns out that information is stored in the brain in the same cells that control your hormone, your cortisol response to stress. So when we look at these cells in the brain of these mice, these cells turn on about 1 to 2 seconds before the mouse makes an escape. If the cells don't turn on, it does not run. And so what uncontrollable stress does is it shuts these cells off so that now you can't engage. And so what we were able to do was we were able to take mice, these mice, and subject them to a controllable stress, teach them that they had outcome control, and now their response to this shadow was back to normal. And so we can do these little tricks, and the response of these hormone control cells in your hypothalamus, that's the area of the brain, went back to normal, right? And so you can use very simple little behavioral tricks to start to change behavior in 2 stresses that are completely unrelated. Where they're not unrelated is that information about those stresses in your brain, although one is visual and one is a shock to your foot, that information eventually ends up in the same cells in the brain that control this hormone response to stress. And so we're continuing with these studies because we're kind of fascinated by this idea that very simple, controlled behavioral manipulations may be able to override what are essentially essentially kind of not freezing responses in people, but an inability to engage properly when you're faced with a stress. So that's one part of the work that we're doing that we're really intrigued by. So Brittany, I'm going to jump to the third part right now because I think we have a little bit of time. So the third part I want to talk about, because I remember there's a second part to this, is about the transmission of stress. So how is it that you can sense the stress of others? And how is it that we transmit our stress to others? And is it all just a one-way negative street? Like, is there any hope in this? Are we just stressing each other out, or is there some benefit? So we look at it from the standpoint of a neuroscientist, a biologist who thinks about evolution and thinks about why these systems might exist. So it doesn't make any sense, right, that I should stress you out. Like, what is the benefit to you by my negative emotional state? Well, the benefit is this, is that these systems originally evolved because simple organisms used these signals when they were under stress to recruit help, right? And that was a survival mechanism. You can see it in plants. If you cut a leaf, leaves release chemical signals, right, to try to protect themselves. You can see it in fish. Fish release chemical signals when they're under duress, and it tells their fellow, species to come and congregate and protect. Just about every species does it, including us. Okay, so there was a beautiful series of papers that came out from a group in Israel that talked about this idea of whether stress is detectable and whether stress is transmissible. So let me explain what they did. So they took a group of individuals who were their test group, and they exposed them to towels that had either been under the armpits of somebody who had exercised or somebody who had gone skydiving. Okay? So you would probably agree the latter is a lot more stressful for most people, right? And so what they asked was this very simple question. So first they said, do you detect a difference in the smell? And they go, yeah, this is a different smell. So they could tell something was different. So what they did was they then took towels and they put a very low concentration of sweat in the towels. And they asked people, do you smell anything? And the answer was no. In other words, they were not consciously able to perceive what was on the towel. But when they put on a heart rate monitor, a skin galvanic response, which measures kind of how conductive your skin is, right? It's an arousal measure. What they found is that people who were exposed to these towels that they didn't know had anything on them from skydivers showed this enormous sympathetic response. But the people exposed to towels from the exercisers did not, right? So that means that we're able to detect, right, an emotional state from somebody else, even through a towel. But what's also cool is that we don't know we're detecting it. And the reason we don't know we're detecting it is that the cells in our nose that detect it, right, talk to cells that are very deep in the brain and bypass that kind of conscious part of our brain, which is our cortex. So these are these old evolutionarily conserved systems that tell the system I was talking about, this hormone release system, you gotta go, before you can consciously decide what needs to happen, okay? And so we did similar work in our lab with mice. And so what we found is that if you stress a mouse and you put it back in its home with another mouse, these are always the same sex and they're always either brothers or sisters. If you put it back in the cage with its brother or sister, within a few minutes, the brother or sister start to show the exact same behavioral symptoms. They show the same hormone response profile, and they show the exact same kind of imprinting in the brain that lasts for 3 or 4 days, even though they were never stressed, okay? What's really fascinating is that you can then take this second, the brother that was not stressed, and then let them interact for about 20 minutes with a third individual, and then you can take the third individual and let them interact with a fourth individual. And every single one of them shows the same brain imprint, even though this one is 3 orders, right, removed from the individual that was stressed. So that tells us that this is a really powerful signal, and that my stress can be, in fact, your stress. And the way it happens is that mice, like us, or us like mice, release what in the literature is called an alarm signal. And the reason they release an alarm signal, and the reason they probably don't just call out, right, and say, is that in the wild, if you think of a mouse in the wild, when there's been a predator attack or it escapes, it probably goes back to a nest and wants to not attract any attention, and so releases a signal that is only detected by those that are very close to it, but it's done without raising any awareness of those who are on the outside. And so it's a really clever system. And so we've been delving into what are the cells in the brain that control this response? Can we manipulate this response? How do we change a mouse's ability to sense this signal? And so we've been working with a close friend and colleague of mine at the University of Bordeaux through a partnership we established between the HBI and the University of Bordeaux. And everyone always says, well, it's because of the wine, isn't it? It kind of is because of the wine, but it's kind of also an awesome neuroscience institute. And so what we've done with my friend Giovanni Marsacano is that we have figured out that there are very specific cells in the olfactory bulb, right, and that's in the mouse that controls smell, that seem to control this ability to detect another stress. So what I haven't told you in all of this, in this kind of transmission and detection of stress, is that we also came across something that was very, very surprising. And that is that in females, and only females, interaction between a stressed individual and another transmitted the stress fine, but that interaction lowered the stress imprint in the individual that was stressed. But it never happens in males. It's interesting, right? So, like, every woman is like, yeah, I got that. I know that's happening. So in females, so it's not a human, like this is amazing conserved thing that in females, you get this decrease in stress. And so we said, well, what if you now bring it back and there's 2 mice? The stress imprint goes down even more. What if there's 3? It's 0. It's like they were never stressed. And so there's something in females that this kind of group interaction seems to buffer the effects of stress. And we have been working for 2 years to try to figure out what this is. And right now, we don't have a clue. We've done every experiment that we thought, got it. Nope, don't have it. So we're still kind of plowing away at this, but I think it's really a fascinating area. And I think it's just an example of how, just keeping your eyes open and just doing very simple biology type experiments in a model system like a mouse can lead to insights that we can think about applying to the human condition. I mean, of course, the reason we're all interested in stress is the neurobiology is cool. That's why I'm interested in it. But the reason we as society are interested in it is that it has this lasting impact, right? It's not the single stress, but it's the over and over and over and over stress. And that chronic stress is the thing that changes on a more permanent basis how our brain operates and how we respond to different situations. And that's the next nut that we'd like to try to crack. Once we have information and kind of a key on how to unlock how individual stresses work, now we can start to layer different types of stresses, go to longer stress paradigms, and ask whether they lead not only to long-term behavioral consequences, but also to long-term hormone consequences. And the latter are also important not just for our brain, but also for our body, right? So cortisol is a hormone that has been implicated in so many things in the body, and most of them are not very good, right? So it leads to, for example, adiposity, fat storage in the midsection, right? So that's not a good thing. It's been linked to enhanced immune responses, increases in circulating cytokines and other inflammatory factors, which we know are over time can have really a profound negative impact on your organs and can also act on your brain, right, to change basic circuits. So I think we're just kind of starting. I know it seems like 15, 20 years, it shouldn't really be a start, but this is the thing with science, right? We never know how the next experiment is going to turn out. So in my lab, we always go, We always make bets on the next experiment. And I always tell people, like, I'm like such an optimist, and I'm always wrong. But I love the fact that I'm wrong, because that means we're really sitting on that kind of edge of unknown. It doesn't matter how much I know. The next step is totally just a shot in the dark. And often, we don't even know what we're looking for, right? And so we have to build this model as we go and find whatever we find and try to change how we think about the brain. And I think, you know, this is where what all of you do, what the MIST campaign that I've been working with Fund Development on over the last year, this is where this becomes so important, right? Science is a challenging endeavor, right? It's an expensive endeavor. It requires a lot of effort from large teams of people. And so if we're going to find these solutions to these societal problems, like trying to understand how stress impacts mental health, trying to understand how repeated stress or intense stress impacts mental health and might lead some to profound alterations in their behavior. It might lead some to things like suicide. We're also trying to understand how physical injury, and this is a new thing that my lab has been thinking about, but there are other labs and other investigators in Calgary who have thought about this a lot, how physical injury like brain trauma or a concussion, how that can lead to long-term behavioral consequences, and whether those kind of physical changes impact the kind of emotional and stress centers that I've been talking about. And so it's only been the last few years that we've started to develop really good models in mice and really good tools that we can start to interrogate and get at some of these questions. And I think in large part, it's because of the philanthropic support we receive. For the most part, our research is funded by federal grants, which are small and very targeted. You ask a question, but most of the interesting things in science happen not with the question that you're focused on, but the thing going on over here. And so how do we jump on those and just kind of make hay? And I think it's the support of the community that allows us to go in these really interesting new directions. So I'll stop there, and Brittany. Yep.
This one works now? Oh, they're on it. Yeah, so I think we just have a couple minutes left before we have closing remarks. So, yeah, a lot to chew on. I like the idea of, you know, control, this thing with control. And I know with a lot of our students, what we do when they're feeling stressed is we have them, you know, draw the bubbles of like what you can control and what you can't control. And let's focus on what we can control, because obviously that's something we can change and it can help lower our stress. So I think my last question is just to Dr. Bains is like, what, from your perspective, what other ways can, now that we know that there's things that we can't control in our lives, big, you know, in my research, big systemic stigma, discrimination things that, you know, humans can't control and maybe rats don't care about. But like, what can we do, like individually maybe, or as a society that like ends on like a good note of like, you know, what are some practical things we can do?
Yeah, that's a great question. I sent my kid to university. That helped a lot, actually. I'm just kidding. No. Yeah, you know, I think this control and absence of control is really sitting right next to the thing that I don't talk about very much, but I think is very, very important. And it's a really important strategy, and that is things like mindfulness, actually. So we know all of these systems are connected, right? So I said initially that stress increased your breathing and increased your heart rate, and but I think if you can find ways to take control over that, right? So when I started my lab, I remember like 21 years ago, before I came here, I had a discussion with a really famous neuroscientist on a plane on a way to a meeting, and I said to him, he said, "What are you going to do?" And so I told him, and I said, "What I really want to figure out is how do we get our cortex, this part of the brain that does all our thinking, how can we get it to override those automatic systems? How can we train it and teach it?" And that's exactly what you're talking about. I still don't think we have a great answer, but I think we're getting closer. As we begin to understand that some of these systems work from sensory information from the world right to these systems, We need to figure out ways, whether they're behavioral strategies, whether they are experimental manipulations like brain stimulation, whether that's combined with pharmacotherapy, as well as behavioral therapies, right? So I think we're getting there. I think we're getting to a point where neuroscience is starting to inform some of the treatments, and I think we're getting closer. I'm really, really hopeful.
Yeah, I'm glad my mindfulness things that I do, like for example, before I MC an event, might actually be helpful. So they help me, but I'm glad the science is behind it too. So thank you, Dr. Bains. It was a pleasure getting to chat with you. Yeah, round of applause for Dr. Bains. So before we welcome James Allen back on stage, so I'd like to share that. So all of you have a beautiful centerpiece on your table, and so you can talk amongst yourselves, not fight, talk amongst yourselves. That it's going to go home with the person at the table whose birthday is closest to today. So you can figure out what that is when we finish the programming. And I'd like to have James Allen join us again to close out the program.
Thank you so much. I gather there are intense birthday conversations happening at every table, which I think is exactly how this should be happening. But let me just say thank you so much. Dr. Bains, that was a fascinating look at an issue that's really important to all of us. But I'd like to thank all of you, our Legacy Society members and guests, for joining us tonight. We like to say that University of Calgary is a place to start something, and that starts with you. Your support brings life to extraordinary ideas, and your legacy gifts will help us keep that momentum going well into the future. So that concludes the formal program this evening, but before we go, I'd like to introduce a couple of colleagues, Sherry Dahl and Blair Nichols. Our Sherry and Blair, there we go. Come on up, please. These are the folks who do the great, great work of legacy giving at the university. And so if you want to learn more about that work, Sherry and Blair would be love to talk to you about this stuff. You can watch your inbox for an email with contact information. We'll be in touch of all these sorts of things. And once again, from myself, from Dr. Ed McCauley, who couldn't be here this evening, from John and the entire University of Calgary family, thank you so, so much for joining us tonight.